My name is Adrianna Pińska. I have a computer science background. I'm a software developer at IDIA. You saw the sign outside. I'm working on the Carta project, mostly on the backend component. So Carta is a tool for visualization and analysis of astronomical image data. We usually refer to it as cubes because it is usually 2D, 3D, or 4D data. The first two dimensions are the spatial dimensions you can see in the sky. Third dimension is usually spectral, so the different frequencies of signal that you get. The fourth dimension usually is polarizations of the signal. So Carta is designed for radio astronomy, and the focus of the project is to scale effectively to the very, very large data that's being produced by modern interferometers, for example, the square kilometer array. And our aim is to provide a responsive interface that researchers can use to navigate even multiple terabyte images. They're already multiple terabytes, and they're only going to get bigger and bigger. So big data is impractical for users to download onto their local computer so they can use their local applications to analyze it. Users need to be able to access this data in dedicated remote storage in an effective way. Big data also requires new approaches. You can't assume that you can load the entire file into memory at once, the way that you might do with small data in older visualization packages. You need to be able to do partial reads on demand from the file. Access patterns are very important. If you're going to be seeking in the files and reading parts of them, it's important to how the file is saved to disk. You may need to save and load multi-resolution data so that you can show the entire image at a lower resolution, or zoom in and show parts of the image at full resolution. Compression becomes very important if you're going to be transmitting bits of data between different components. And parallelization on CPU or GPU can also be very important for either for calculations or for rendering the visualization. So the design of Carta attempts to do this in an effective way. It has a client-server architecture. There's a backend which runs on the server near the data, while the front end is a web app which runs in the user's local browser. And so the data is sent from the backend to the front end as it is needed. These are mostly progressive asynchronous updates which don't block the user's interface, which is being executed entirely locally. So the user interface can remain responsive. All the rendering happens in the front end, which means that the front end can utilize the user's local GPU in their computer through their browser. We also have a custom schema which we've developed for astronomical data, which we're currently using with the HDF5 container format, which stores the data in a chunked format to make it easier to read parts of it. And we also have additional cache data sets that improve certain very slow tasks. So for example, we store pre-generated downsampled data at various resolutions, and we also store a rotated data set so that the reads along the worst, least contiguous axis, for example, for spectral profiles, can be sped up because you can use the rotated data set instead. And so there are additional components. There is a controller for managing multi-user environments. I'm going to speed up. The important thing is that you can also run Carta locally on your local computer, and you get pretty much the same experience, which is consistent. Its backend is written in C++. The front-end and controller are written in TypeScript. All of our code is open source, GPL version 3. It's on GitHub. We use a lot of open source libraries, very useful. We have a lot of packages that you can use to install the code. We have collaborators in Taiwan, South Africa, United States, Canada. You can see the logos. And we have a new partnership being finalized, but it's not official yet. And most of our communication as a team is through GitHub and Slack. We have an annual in-person meeting. We have 10,000 users, so they seem to like the software. We have good engagement from the community. And our challenge right now is maintaining a large and complex code base with this distributed team. We're currently preparing a version 6 beta release, and we have a big code maintenance and refactoring push. And you can go to see our website and our organization on GitHub to find out more about us. Thank you.